Welcome to The Explainer. Today, we're diving into a question that is absolutely fundamental to our digital lives, but, it's something most of us never really stop to think about.
Right. Every single time you send an email, stream a movie, or just load a web page, you are launching information on this incredible globe-spanning journey. And it's all thanks to the epic, split-second voyage of a tiny, unsung hero, a single data packet. So let's do this. We're going to follow one of these packets as it navigates the huge interconnected web of digital highways that we call the internet. Our mission? To really understand how it gets from your screen to its final destination, pretty much flawlessly, millions of times a day. Now, to really get a grip on our packet's trip, we need to understand two key jobs that happen in the internet's network layer. Just think about it like a road trip, right? Before you even get in the car, you need a map, a plan. But then, along the way, you have to actually make all the turns. And this slide, it really gets to the heart of it. On one side, you've got routing. That's the big picture, the plan for the entire journey from start to finish. And on the other, you've got forwarding. That's the immediate, split-second decision you make at a single highway interchange, to get onto the next road. So, to put it simply, routing is that global process, figuring out the path. But forwarding, that's the local action, the actual moving of a packet at a single crossroads. And it's this high-speed forwarding, which is also called the data plane, that we're really going to focus on today. Okay, so our packet has just left your device and it's arrived at its first major crossroads, a really specialized piece of hardware called a router. You can just picture this thing as one of those massive complex highway interchanges. A router has one main relentless job. Grab our packet from an incoming road, an input link, and blast it out onto the correct outgoing road, or output link. And it has to do this at just mind-boggling speeds. We are talking about operations that happen in nanoseconds. It's almost insane. This whole internal journey is actually a surprisingly simple three-step dance, and it's all handled by specialized hardware to just eliminate any delays. The packet arrives at an input port, it gets zapped across this high-speed network inside called the switching fabric, and then it shoots out of the correct output port. That's it. Speed is absolutely everything. So that kind of begs the question, right? With billions, literally billions of possible destinations on the internet, how does the router instantly know which output port is the right one for our little packet? I mean, it can't possibly know every single address, can it? Well, the good news is it doesn't have to. It uses this really clever shortcut called a forwarding table. The best way to think about this is like a compact, super high-tech set of road signs that lives inside the router. It's the router's own internal address book for directing all the traffic. And here's the really clever part. This table doesn't list every single house number on the internet. No way. Instead, it lists address prefixes, which work almost exactly like postal codes. So a single entry in this table can cover thousands or even millions of addresses in one specific neighborhood of the internet. To decide which road to take, the router follows one simple but incredibly powerful rule. Always find the most specific direction available. So if it has a choice between a sign that just says California and another sign that says San Francisco, it's always going to choose the San Francisco sign. This principle is called the longest prefix match, and it's what makes sure your packet is always sent on the most precise path that router knows about. Okay, let's keep going, because this is where things get a little surprising. After all this incredible high-speed engineering we've been talking about, the internet doesn't actually guarantee your packet will arrive safely or on time or honestly, even at all. Yeah, it operates on a model called best effort service, and it is, well, it's exactly what it sounds like. The network promises to simply try its best to get your packet where it's going, but it makes absolutely zero guarantees about the outcome. Some other specialized networks, like the old-school telephone system, they were built on guarantees. They guaranteed things like delivery and timing, and that everything arrived in the right order. The internet, though, it chose a completely different path. It prioritized simplicity, flexibility, and raw speed above everything else. And while that might sound a little unreliable, this no-frills approach is actually the secret to the internet's incredible success. By keeping the core of the network simple, it allowed the internet to be deployed super rapidly and cheaply all across the entire globe, connecting billions of different devices without needing some complex central authority. So let's just do a quick recap of our packet's journey and give credit where it's due. All of these local per-router actions, that's the work of the internet's real unsung hero, the data plane. So the packet enters a router, its address gets checked using that longest match rule, and then it gets zapped to the right output port. That whole process, That is the data plane in action. It's a simple, repeatable dance that happens at every single hop along the way. And what's truly staggering is just the sheer scale of it all. This isn't happening once or twice. The data plane is the real workhorse of the internet, making trillions of these local forwarding decisions every single second across millions of routers, powering literally everything we do online. So, if there's one thing to take away, it's this. The internet's wild success came from a really radical design choice. Build a simple, fast, best effort network, and just let the computers at the edges handle all the reliability stuff. That choice created the world we live in today. And as we look to the future, it really makes you wonder, doesn't it? What core principles will end up shaping the next generation of global networks? Thanks for watching.